we will try to understand cross virtual network connectivity with peering. So that's our topic. Let me write it down. Virtual network connectivity with peering. So this is what we need to learn today. So in a very simple way, if we need to understand, let's suppose this is Azure. So what are we understanding? Peering. Okay, this is Azure. Now in Azure we have tenants, right? Uh, this is like the Azure or everything Azure. On Azure we have this one tenant, or maybe you can say this is one subscription. Let me create it this way so that we can cover multiple scenarios. Or let's forget it, we'll do it later. This is Azure. Inside Azure we have multiple virtual networks. Okay, this is one, this is another one, this is another one. These are the virtual networks. VNet 1, VNet 2, and VNet 3. Now the scenario is clear. On Azure we have created three virtual network, or we have three virtual network. We are not discussing any tenant, subscription, and region as of now, though there is not much limitation, but just to be on the same page, it's just multiple virtual network on Azure. Now if we want to establish connectivity, because that's the topic, between VNet and VNet 2, there might be some virtual machine here who wants to talk to the virtual machine VNet 2, or on VNet 3, or maybe this VNet 1 is your shared services virtual machine where we have the firewall or maybe Active Directory. So or everything in VNet 2 and VNet 3 need to talk to VNet 1 so that they can utilize the shared services in VNet 1. Ultimately, there may be any reason, but we need to connect VNet 1 and VNet 2. So in Azure, there is a very simple and beautiful way of connecting to virtual network is called peering. Through peering, we just need to give the information VNet 1 about the VNet 2 and VNet 2 about the VNet 1, and they can talk to each other through peering. So in simple words, peering is a mechanism to connect to virtual network on Azure so that they can talk to each other, or resources inside the virtual networks can communicate with each other as if they were part of the same network. It's very important, as if they were the part of same network. Why I'm saying that? Because that's the reason I created Azure, because everything is on the Azure. So they're not going outside the Azure and talking to each other. They are utilizing Microsoft backbone infrastructure, meaning no public internet is involved, ensuring low latency and high bandwidth. Just to understand it further, let's suppose there is a on-premises network. Now, how will on-premises connect with virtual network in Azure? Through site-to-site connectivity, right? And this site-to-site connectivity happens how? Over the internet, right? There's an internet, and this is VPN tunnel, encrypted tunnel over the VPN, right? So this data, the data that will flow between on-premises and Azure will go over the internet, but here it is MS backbone. Clear? Now, keeping this in mind, MS backbone virtual network become one single network, though both has their own individuality, both managed separately. You have the services like NSGs or firewall to take care of the traffic, but still they become part of the same network. Now let's try to understand few more things about peering, because Now we understood the conceptual part of it. Now let's find out the key features of it. The very first is it will give the private connectivity. Okay. Now, as you see in the here VNet 1 and VNet 2, the resource from VNet 2 can talk to VNet 1 privately, just like we defined virtual network in our very first video. And this communication happens over Azure's private backbone, ensure high security as well, because it is Microsoft's backbone and no internet. So it will be secure. And it would be, we mentioned low latency and high bandwidth. Okay. And these are some reasons why we choose peering to connect, right? And there is this independent management and then to management, and you can utilize NSGs or firewalls, NSGs and firewalls along with UDRs, which is user defined routing, uh, to take care of the traffic for traffic control. Okay, good. Now let's suppose, so this part is done for now. If you are utilizing not peering but something called gateway running on VNet 1 and running on VNet 2 and connecting through VNet to VNet, just like VPN tunnel, you are connecting through tunnel through the backbone, then it would be higher cost because there are two gateways that you have to spin up, right? Uh, and if you're utilizing any other third party, then you have to buy another resources. So this peering is also cost efficient. Okay, cost efficient. And when you create peering, there is no downtime required, right? So these are multiple wonderful features that will help you to opt for peering for connectivity rather going for any other options. One more thing, if you have a gateway, because we were talking about shared services in VNet 1, just an example, you might have a gateway here which is talking to on premises, the same thing that we have presented here. Now VNet 2 or VNet 3 can also utilize the same gateway. There are settings, there are configurations that can be done, so the gateway can be shared gateway can be utilized through peering as well, right? So these are multiple features that will help us when we go with peering, right? Now there are certain things that we also need to be aware when we talk about peering. For example, let me open another screen here. For example, if there is this different subscriptions, let me make it subscription 1, subscription 2. Okay, so this is the VNet in subscription 1 and this is a VNet in subscription 2. So what do you think? Can you peer between these two? Yes, you can. So peering can be done. There is no limitation here. But both the subscriptions must be associated with Azure AD tenants that allow peering. That's a tenant level settings that needs to be checked, which is usually yes. And the people who are configuring the peering must have the permission to do so. Now, you need to be aware there should not be any overlapping IPs. Okay, overlapping IPs. If IPs are overlapping, then they will not connect. Now, let's suppose these two are in different tenant. Okay, let's suppose there is tenant 1 and this is tenant 2. Now, this VNet is in tenant 1 and this VNet is in tenant 2. Now, would we be able to utilize peering facility for the connectivity of the virtual networks? Yes, we can. It is supported. However, you need to be aware there are some tenant level settings that needs to be checked. You need to ensure that there is necessary cross tenant permissions are granted. Cross tenant permissions. All right. You need to generate a peering authorizations from the source VNet in one tenant and use the token to configure the peering in the target VNet in the another tenant. And both tenants must have public or private access configurations that allow interconnectivity. Ultimately, the point is it is supported. You can connect peering into different tenant, different subscription, and if you have one in region 1, let's say this VNet is in region 1 and you have another VNet which is in region 2, doesn't matter in different subscription. Now we are focusing on a region. They can connect to each other through peering, but this time we call it global peering. And how it is different than normal peering? There is some difference, not much but little bit, because it will be little higher in cost as compared to the normal peering, because now data is moving across the region, so there would be little charge in both ingress and egress, right? However, the shared gateway and things like is all supported, only the this thing higher cost. Okay, if we're talking about service endpoints, these are not supported in global peering. Okay, do not work across global peering virtual networks. So the things that we need to remember, the very first is no overlapping IPs. Okay, we have NSGs, network security groups, and UDR rules that we create to control user-defined routes. We configure the rules in NSGs to control the traffic between the peering. And one more thing, no transitive by default, but you can achieve it through NVAs or UDRs, right? So what is transitive here? Okay, let's try to understand transitive. Let's suppose this is okay, let's go here. This is VNet 1 and this is VNet, this box is VNet 2. Let's suppose there is another VNet. This is VNet 3. VNet 3. Now VNet 1 paired with VNet 2, there is a pairing, and VNet 2 is paired with VNet 3 pairing. Now this VNet 1 can talk to 2 because pairing, 2 can talk to 3 because pairing. So what do you think, 1 can talk to 3 or not? If it can, then it would be transitive. If it cannot, then it would be no transitive. So pairing is no transitive. So if VNet 1 and VNet 3 is not explicitly paired, they cannot talk to each other, or there is some kind of service like NVA in place which will read the traffic and allow to go there, only then it can be done, right? So it's no transitive routing. All right, so let's go ahead and create one more slide here. Now here we will talk about some design consideration for peering, which is absolutely important. We need to understand this design considerations when we do peering. Okay, so what are those? The very first is uh, just to make it a little interesting, we have VNet 1 and we have VNet 2. Okay, what are we trying to do? We are trying to do peering between these two. Now the very first thing is non-overlapping IPs. That's the first requirement. If it is overlapping IPs, they cannot connect to each other, right? Okay. Now we also, because of now we are thinking from the design perspective, so now you need to plan the address space to accommodate future subnet expansion in both the subnets, because we need non-overlapping IPs. And if you do not give that expansion for the future growth, you might come up with the overlapping IPs and there would be issues, right? Or you need to just rethink the entire network topology. So you need to think the future growth as well, and then assign the address spaces to your virtual networks and peering. Now we talked about this peering can also help you connect your workloads that need to communicate while keeping other resources isolated. So you just peer and forget it. No, it's not like that. You peer and then you do the isolation, proper segmentation utilizing your firewall or NSGs, right? So you need to think from the holistic perspective, the entire design. Peering is only one part. After peering, everybody can talk to everyone between both the virtual network. But now you need to also think from the segmentation perspective. You need to also think from the isolation perspective and apply services like NSGs and firewall for the proper isolation for security reasons. Now, by default, when you create peering, these people can talk to VNet 1 can talk to VNet 2, and VNet 2 can talk to VNet 1 by default, which means default routing that Azure creates will allow both way communication. And we don't want that. We want to control it, right? And you know what is there to control? We have something called user defined routes, UDRs. And UDRs will help us to define the routing and apply it on the subnets, so that we can control whom to talk, how to talk, and via who to talk. For example, it is very interesting. Let's suppose, again, let's go to the hub and spoke scenario. Let's suppose this is your VNet 3, which is your hub subnet, hub virtual network. This is your spoke VNet 1 and VNet 2. Now here we have firewalls. Okay. Now, and these two are connected to this hub subnet through peering. Now we are understanding UDR here, this particular concept. Now UDR says if VM1, let me create some VM here just to make it good. And here we have firewall. This is our firewall, and here we have some VM2. Let's call it VM2. Okay, so if this VM, let me get the pencil. If this VM wants to talk to VM2 here, it can directly talk to this, because if they are paired, okay, if there is a connectivity established, they can talk to this. But in ideal situation, we got to secure the traffic. So what we do, we apply here what UDRs. We apply this UDR on the subnet where this VM is running. Then when this VM try to talk to this, it will go to the firewall. Then firewall will decide whether it is allowed or denied, right? So what is UDR? UDR will change the direction of your traffic. This VM, this VM will not go to VM2 directly, but it will read the UDR and go to firewall, and the firewall will send it to here. This is what UDR is, that we should utilize for transitive routing as well. Now, we talked about global routing in the previous slide. Now here we need to think, because this is design consideration. If VNet 1 and VNet 2 and this hub, usually they all are in the same region, then it is fine. It's low latency. However, let's suppose there is another VNet here, VNet 4, and this is in a different region. If this VNet is in a region 2 and above all the VNets are in region 1, In that situation, you need to also think from the perspective of latency. These are highly low latency because they are in the same region. But if you have to cross the region, there will be little higher latency as compared to this local peering than global VNet peering. And of course, you need to plan for egress and egress cost for global peering. Right now, we were talking about gateway, sharing gateway or gateway transit. We can also talk about that now. Let's suppose this there is no peering here, or it doesn't matter. Let's suppose this is let's create here. Mm, this is on premises right here. I'm trying to create another uh, architecture just to make it more comprehensive. And let's suppose there is this is hub virtual network and this is our spoke virtual network right here. Okay, these are connected to each other through peering, and these are connected to the hub through VNet to VNet VPN. This is hub, and we have here gateway. Which gateway? VPN gateway. And this is our spoke VNet, which is connected to hub to utilize the hub services, and this is VPN tunnel. Now, this gateway, though these are non-transitive, but do not confuse here. This gateway, which is connected to on premises, these can talk to each other without any issues, right? Now, we can allow this POC VNet to utilize this remote gateway and talk to the on-prem resources, and this is called gateway transit. But you need to ensure that gateway capacity supports traffic from all peered virtual network because it will increase the traffic, right? And we will see that under the settings. This is remote gateway for this, and you need to allow transit. So that can be achieved. Gateway sharing. Now, we know tenant is not a limitation, subscription is not a limitation anymore, and little settings here that you need to see, and it can work pretty fine. Now, if these VNet, VNet 2, VNet 3, if these need to uh, utilize name resolution that we were learning in previous videos, they can simply use one DNS private zone if it is all private, and this can be linked to both, to all the three, 1, 2, and 3, and they can utilize all the records here and do the name resolution as well, right? So we have covered a lot of things here. Okay, one more thing before we close this uh, session is monitoring and diagnostics, because Azure Monitor and Logs, because this is something that we should be aware of from all the perspective, because we should know where the traffic is going, who is looking into it, who is accessing, what is accessing from the security perspective, because we know we got to run everything secure. So we need to enable network monitoring to visualize traffic between peered virtual network. Yes, you can visualize through network monitoring, which is a part of Azure monitoring. And there is something called Network Watcher, which will help you to troubleshoot a lot uh, network related issues. We also have something called traffic analysis that we can do with the help of Azure Firewall or any third party firewall like NVAs. We can get all that information, even the NSG's logs. We can put it somewhere like Sentinel or Log Analytics and run our analytics there also, right? Okay. Apart from this, I think this is all about peering connectivity and design consideration. Okay, we'll see some settings in the next video. Don't want to extend it too much. I hope it is useful and you learned something new today. Thank you for watching. You guys have a wonderful day and Happy New Year. Bye.